I wanted to start this lecture by recapping some stuff that we talked about last week. That meat is composed of muscle tissue and connective tissue. And the connective tissue is generally what we think of as giving meat its toughness. And I'll talk again about that in a moment. But let's just remember what meat's all about. In these USDA quality grades, we're talking about prime, choice, and select as typically what you're going to see in a reasonable grocery store, and that has mainly to do with the degree of marbling inside the meat. Prime having the most marbling, select having the least marbling. Now, the marbling is going to have an impact on flavor, obviously, and texture and tenderness, but it's interesting to recall that, as your textbook states, the definition of prime has changed over the years as our society in the United States has tended to favor leaner and leaner cuts of meat. So what 20 years ago might have been choice or select is now prime. All right. As an interesting side note, I jogged down to my local grocery store, Foodland, which is definitely a low rent food grocery store, and there were neither prime nor choice nor select at that grocery store. It was all store brand. So, but again, reminding you that that isn't necessarily a reflection so much of it's not a reflection of the quality of the meat to any greater extent than the degree of marbling. And again, we can go all the way down to the kinds of meat that you'll never see sliced as steaks or other cuts. That's the utility grade, mostly going into processed meats. Well, we talked about the yield grades. That really has to do with how much meat those animals put on. There were also questions about why there are so many cuts of meat, and I thought I emphasized this last time around, but here it is again. This is a great photograph or a great image showing you one version of the kinds of ways that we can cut cattle into pieces, and this changes to a certain extent regionally. For example, at least up until recently, in most parts of the country, you wouldn't see tri-tip as presented as a piece of quality meat. It might have been converted straight into ground beef. As for the different flavors, I'm sorry, the different varieties of meat, well, they have mainly to do with whether the meat has got a large amount of connective tissue, as in the forelimbs and hind limbs, or whether it has a lesser amount of connective tissue, making it more tender. And those are what we typically are going to see as steak cuts as opposed to roast steaks, right? All of these haunch and forelimb cuts are mostly going to be used for roasting. And why is that? Well, remember, the longer we cook that meat, the more connective tissue we're going to degrade, and the more tender the meat will become. If you try to cook that roast on the grill, you're not going to cook it long enough, and it's not going to be a very pleasant eat. Again, using beef, here's one: beef for stew. Again, you're going to be simmering that in some broth for an extended period of time, and the connective tissue is going to have time to break down. Otherwise, these are all fairly tender meats. Of course, the sirloin being the most tender and also the least encumbered with bones, right? There are these two classes of steaks are often going to come with bones, unless the bones have been excised on purpose, and so the sirloins will consider to be the highest quality for that reason. I also wanted to revisit this idea: what is red meat? What is white meat? Again, mentioning that red meat is any livestock animal, and the USDA considers that to be beef, pork, lamb, or goat. You might be able to think of a few others that might fit that category, whereas poultry and fish are considered white. And really, whether it's red or white, beyond this USDA definition, has to do with the quantity of myoglobin. White muscle tends to be fast twitch, right? So this is fast response muscle, which is why we're going to see it in large quantities on chickens, which are flapping their wings to get away from predators, perhaps. And those muscle fibers depend on glycogen or sugars for energy. Slow twitch or red fibers are dedicated to more extended period activity, and their thinner fibers allows oxygen to get into the muscle tissue more easily, and once the oxygen is there, it's going to bind myoglobin, right? So myoglobin, the protein that binds the oxygen, is going to be present at higher density. They're also dense with mitochondria, which I tried to show you over here in this slide. These are cross sections through mitochondria. These are the, if you haven't had much biology, then let me tell you, the mitochondria are considered to be the energy powerhouses of the cells, and they generate most of the energy that's available to the cells in the form of ATP, which is that chemical energy currency, adenosine triphosphate. So those mitochondria are also dense with proteins that contain hemes. Remember, we talked about that. I'll mention it again in a moment. And those hemes are reddish or brownish colored. So this lends that dense coloration to red meat. So as well as being dense with mitochondria and myoglobin, this is also, red meat is also dense with fat deposits, adipose tissue, again intramuscularly, so that there is an energy source readily available to the mitochondria for the generation of ATP. This is a nice photograph again, not stained for muscle fibers per se, but it is muscle tissue stained for a mitochondrial enzyme. So again, we see that in the red tissue, we're denser in mitochondria than we are in the white tissue. And in this case, we have some white fibers and some red fibers intermixed, and that's not, it's not necessarily a one or the other sort of organization. One more, maybe two more slides on meat color. And again, this is reiteration because I felt like there was still some confusion. The meat color comes from this heme molecule. This is a small organic molecule that itself, its only job is to bind an iron atom. It binds other atoms, other kinds of metal ions in other situations, but in terms of myoglobin, it's iron. So the presence of that iron alters the color of the heme, and the iron and the color itself also depends on what kind of molecule is bound to the iron itself. Oxygen and carbon monoxide, note that the chemistry of those two molecules is quite similar. They both bind strongly and give off this bright red color, whereas when we are deoxygenated, and this also is independent of the oxidation state of the iron itself, when we have water, for example, bound, we are purplish or brownish. So that accounts for the color change. This again I mentioned this already and I gave you reading about this, I'll keep mentioning it, right? We can affect the color of the meat in the grocery store by pre-treating the meat with carbon monoxide and then shrink wrapping it, so it will appear to our eyes, which associate red with freshness, to be fresh for longer, whereas really it's not freshness is not necessarily indicated by that oxygen, by that red color. However, that notion sort of comes from the idea that we start out oxygen bound, and then we go to the store, and then over time the oxygen is unbound, and we replace it with water, for example, and that results in that color change that we're familiar with. I also want to take this opportunity to remind you that the longer meat is off the bone, right, longer after the slaughtering of the animal, the tenderer the meat is going to become. So that degradation process starts immediately, and that's why meat will be aged. So high quality meats are often aged under very specific conditions, and that slow degradation leads to a more tender product. So freshness doesn't necessarily mean best. Last, I wanted to introduce this picture of myoglobin. This is a sort of a chewing gum cartoon representation of myoglobin. We've looked at protein structures early in the semester. I'm throwing this at you again. This is a very highly simplified drawing of the protein. Here's one end of the chain. You can see that it forms these complicated local structures, but then it wraps together into this more complicated global structure. In one perspective, myoglobin's only job is to sit there binding that heme. It has a very specific binding site that admits that big heme molecule, and you can barely see the iron bound there at the center of the heme. And this little set of sticks is supposed to represent the oxygen molecule itself. So we got oxygen bound to heme, bound to myoglobin, and myoglobin is the oxygen storage molecule of red muscle tissue.